Hey there, kids. Today we are covering Module 2, Lesson 18 in our Eureka Math. And so just a few little notes to kind of point out what we're working on and why. We're using basic facts to approximate quotients with two-digit divisors. So in previous lessons, we had, just had single-digit divisors. And so in lessons 17 and 18, 16, 17, 18, we're starting this method so that we'll be ready for the big standard algorithm with large divisors. And the way that we're going to do this is always by thinking about what that divisor is. And so, as in previous lessons, we need to know to round the divisor first. So a couple of practice problems just to help you warm up. If you had something like 8,095 divided by 23, if you round the divisor first to 20, then we're going to keep a number here that is a multiple of this number. Now this one's pretty easy. 23 rounds to 20 and 8 is already a multiple of 2. And so then we can follow the steps that we had learned previously where you can have these divide by 10 both sides and then divide by 2. And so that would be the 800 divided by 2 is what's left, and you get your 400. So it's pretty easy using some of the same strategies. But the numbers are going to get a little bit bigger, a little bit more awkward with your rounding. So just to kind of point out, look for things that you can do with your options that will make it easy for you. Remember, making it easy, that's the goal of estimating. So here we have our 48, round the divisor first and make it 50. So we wouldn't necessarily need to go all the way up to 30. You want to have something that's pretty close. So going down sometimes is a better option than going up. 25 is a multiple of 5, so you can change this to 2,500, not 2,600. Okay, not 2,700. 26 and 27 are not multiples of 5, and you have to use a multiple of this number that you have rounded first, okay? So you end up with your 2,500. You have your offsetting zeros, which, because if you divided both sides by 10, that would leave you with 250 divided by 5, and then you can have your 50. Same thing here, kind of a simple problem, 71 rounds to 71st, and then you want to look for a multiple of 7 that is close to, and I always just say the first two digits, close to 54. Just ignore the rest of it, except for the fact that it's a 4-digit number. You should have a 4-digit number. And so then 56 divided by 7 is 8, and then you've got your 1 0 left after you divide both sides by 10. Now this last one is a great example of some of the harder ones in this lesson, and it's taking a number like 9,215 and dividing by something, and wherever it's in the middle, like with a 5. So 95. So let's say, what are your options? Some kids will say, let's just round up to 100. But some kids will look at this 9 here and say, let's round it to 90. And other kids will look at the whole problem and see that 95 could also be close to 95. And the answer key is pretty clear here. It always will say, answers may vary. And so really depending on how you see it, these are all different options for how you can round, not just the divisor, but how you can round your dividend too. Okay, so those are the notes for today's lesson, and then we'll jump into the book. And again, once you get going and you see that there's a little pattern developing, it really starts to roll quickly. Okay, so we round the divisor first, choose a multiple of this number. 6 is a multiple. You do your offsetting zeros, have 600 divided by 2. Notice that we don't have all the steps that we did previously. So it's okay if you do some of your slashing. There's going to be less work compared to the previous lessons. And so 6 divided by 2 is the 3, and then each 0 comes down. Okay, so you have 200, or 2 zeros left for that 100. So you get your 300, okay? Round the divisor first. I can't say it enough. Round the divisor first. Now I'm working with multiples of 3. Now, if you look at 2,659, I wanted to say 2659 because That's kind of what I would do if I were not teaching right now. But 2,659. And think about what numbers are close to or a multiple of 30, close to this. My instinct would be to say 2,700 because 27 is going to be the first number that you get to. Now, interestingly enough, the book says as a recommendation that you could go all the way to 3,000. I don't think that's a very good estimate. I think that would be the second best. So I really prefer doing the offsetting zeros, and my answer would be 90. And then the book says, oh, the kids might still be thinking in terms of tens, and so then their answer would be 100. So I'm saying I like this. Book says we like this one. Whatever. Estimates may vary, so they're both correct. Okay? And I hope you can see that it's going to be, some people will have different answers than you will, and it's okay. Round the divisor first. I'm going to use 30 because that's pretty close to here. I want a multiple of 3. 9 is already a multiple of 3, so I'm just going to drop all that and make it 9,000. Change everything to zeros and make it 9,000. Offsetting zeros, divide both sides by 10. That leaves me with 900 divided by 3 for 300. Let's do another one. See how the pattern starts to develop? Round the divisor first. Now find a multiple of 5 that's close to, and I always just say first 2 digits, let's start there. Close to 14, multiple of 5, let's choose 15. How many digits are left? 2. Make sure if you have 4 digits here, you have 4 digits here. So it's not just 15 divided by 50. It's got to be 1,500 divided by 50. So make sure you have the right place value positions. Offset your zeros. 15 divided by 5 is 3. Don't forget to bring this other 0 down. Round your divisor first, 60. Now I need a multiple of 6 that is going to be close to these numbers. So 25 is a little higher, but let's go with 24. 100, 1, 2, 3, 4 places, 1, 2, 3, 4 places. Just double check yourself. Divide both sides by 10. So cross out a 0 on each side. Divide 24 by 6 to get 4, but don't forget that 0 for 40. What do you think you do first? That's right, round the divisor first. Now I need a multiple of 7 that's close to 22, or look at these first 2 digits. Come up with a multiple of 7, like 21. Count your place value positions. Make sure you have 4 digits. Offsetting zeros, divide both sides by 10. 21 divided by 7 is 3, and the 0 comes down. Okay? Starting to see a pattern? Yes, I am. Just when you think you got it all figured out, notice they had 4 and 3 and 4 and 2, so everything kind of rolled down. Now we have a 5. Now this is what I was talking about in the beginning, in the notes. The 5s can go up, they can go down, they could stay the same. So now you really have to start looking at, what do I want to work with over here? Now this is really close to a multiple of 7. If you know your facts, these are going to be so much easier. So this is easier to round the divisor first to 70 as opposed to 80. If I rounded it to 80, then I would have to find a multiple of 8 that is close to 49. Could I use 4,800? Yes, I could. And so you can go either way. Remember, answers will vary. So some person may choose 70 and some person may choose 80. And whatever they choose is going to change their dividend. Okay? So if I say this is 70, then this would be 4,900. If I say this rounds to 80, then this would have to be 4,800. Okay? Either way, for this one, I'm going to offset zeros and get 70. For this one, I'm going to offset zeros and get 60. And so they're both pretty close, but again, answers may vary. It just depends on who thinks of it and which way they want to go. For this one, a little bit easier. Round the divisor first. Ones usually just go to there, but think about what we have here. And this is where people may come up with something different. Someone may use 8,800 and go with the 11. and someone may use 8,000. And so if you choose something that's easy for you, divide both sides by 10, and then you might end up with something around 100 for your estimated answer. For this one, let's go with rounding the divisor first. What a surprise, right? And then a multiple of 9. I would probably just choose 9,000 because I have easy offsetting, and then you're going to end up with 100, and it would be pretty close. If I had gone with something that I went down instead, so if I divided by 90 here, see, that's going to be a multiple of 9 there. So if you go up 500 or if you go down 400, you're going to have good answers either way. Okay, and so that one would be offsetting zeros, and you would get 90. And 90 or 100, those are both pretty close. So see what I mean by answers may vary? They will vary. So you could even text your friends and say, what did you get for this one? Okay, rounding the divisor first will give me about a 70 here, but I want to look at the first two digits and say, well, what is a multiple that's a multiple of 7 that's close to 39? And so we're starting to get kind of in between, because 39 is not a multiple of 7. So you have to think about what are the multiples of 7? And so 7 times 5 is 35, and 7 times 6 is 42. So you might recognize that 42 seems to be just slightly closer than 35. And so you could use 4,200. But some other kids will say, I would really rather use 3,500. And you'll all be pretty close by the time you do the division with your estimated number. Okay? So 60 or 50, you'll be pretty close. Rounding the divisor first, and then choosing a multiple of 8 that's close to 51. And again, should we go with the 6 times 8 for 48, or should we go with the 7? 6 or 7? So what do you think? Let's go with 6, and we'll change it to 4,800. So you have options. People will take it and offset and then divide. Okay? Rounding the divisor first. And let's choose a multiple of 9 that is pretty easy and close to that. Some people may say, let's go up. What are our multiples of 9? So if I have 9 times 5 is 45. So that could be 4,500, which would be okay. But 9 times 6, there's that too. So just depends on what you choose. Let's just go with the original one, offset the zeros, and get 50. And let's see. Hopefully that didn't pop up there. Just a little app update. I don't want to update right now. No thanks. Okay, for this one, I'm going to look at this and think about, should I go up to 100 and then make this an even 5,000 up, down? Remember, that'll give me a pretty good estimate. Or should I go with 90 and then stick with 54? So some kids are going to want to make it really easy and stay with those 10s. And I'm telling you, you want to try to get away from the 10s and really look towards those easy, basic facts. And so here we have our 60. Next one, real quick, let's wrap up this page, 86 to 90, rounding the divisor first. A multiple of 9 that's close to 69. Well, sometimes if you think about something that's lower, it's farther away, and so sometimes you have to go higher. If I have 9 times 7, I get 63, but 9 times 8 is 72. So 72, even though it doesn't resemble a 69, it's actually closer. So then do your offsetting zeros and end up with your 80. And the last one, again, they chose a fun one with a 5 in the middle. So do we go to 10? Do we go to 20? Do we leave it at 15? What should we do? And if you know that 15 times 2 is 30, you could actually leave this here and change this to 3,000 and then have no offsetting zeros, but you can take your 30 divided by 15. That's where you get your 2, and then each 0 comes down. And that works as well. Okay? Woo-wee. So that is a lot of boxes. now we have some word problems, and these are fun. So a swimming pool requires 672 feet squared of floor space. Remember that when we find area, it's length times width. When you see that little 2, that means feet squared, so they're giving you the area right here, okay? So they have already done the length times the width. They give you this, the length of the swimming pool is 32 feet, so estimate the width. So if you take this formula and you fill in what you know, 672 feet squared equals length of 32 feet times mystery width, W. Then we have our this times this, the factor times factor equals product. But you know that in a fact family, if I had 2 times 3 equals 6, I could flip it around and do 6 divided by 3 equals 2 because the opposite is true. So we're going to do that here, and we're going to take our 672 and divide by 32. But today we're estimating because we just want to know the estimate of the width. So if you round the divisor first and come up with your 30, then I want to have something that's pretty close to this. Now, you might see that you have a couple of options. If you chose to take 672 and make it 660, okay, you could use that. But some people will just say, I see the 6 and I'm going to go all the way down to 600. So these are the options that you have to deal with. So let's just keep it rounded, offset our zeros, divide 6 by 3 to get 2 and 20. And so you can say the width of the pool is about 20 feet. Check your label and make sure it's the same because they're going to have feet, feet, and this would be feet. Okay? Let's do another one. Janice bought 28 apps for her phone that altogether used 1,348 megabytes of space. If each app used the same amount of space, which is highly unlikely, about how many megabytes of memory did each app use? So that's a fancy way of saying 1, and then show how you estimated. So we have our total amount, okay, so look at the total, our 1,348, and then it's divided by these 28 apps. It's divided by the 28 apps. Remember in previous videos I've said, watch for things being shared equally, okay? So this is a shared equally event here. It's taking all the apps, the memory, and then dividing it by the apps, and so it's sharing evenly. Round the divisor first, and then come up with a 4-digit estimate that is a multiple of this number. This is pretty close to 12. So if you change that to 1,200, remember we're just estimating. Do your offsetting zeros, divide 12 by 3 to get 4, and then that other 0 comes down here. So about how many megabytes of memory did each app use? Each app used about wavy equals 40 megabytes of space. There you go. Now, part B. If half of the apps were free, woohoo, how many apps did she have? Half of 28. And the other half were $1.99 each. About how much did she spend? So what's half of 28? You can do that by doing 28 divided by 2. And then you will see that 14 of the apps were free, which leaves 14 at $1.99 each. And that's money. So when we have a multiplication problem and we're still estimating, you can round to about $2. Now, $1.99 is only 1 penny away from $2, and that creates a very easy multiplication problem for us. 14 times 2, which is basically what we just were at. So we halved it, and now we're going to multiply 14 times $2 to get $28. So about how much did she spend? She spent about $28. Okay, getting close. Oh yeah, if you like these videos, click subscribe and come back again because I'm going to do more. A quart of paint covers about 85 square feet. Always look for those abouts. About how many quarts would you need to cover a fence with an area of 3,817 square feet? Notice that they put square feet in words, but up here previously it was feet squared with the abbreviation and the exponent. It's all the same thing, so don't let that throw you off. They like to keep you on your toes. So take your 3,817 as the total, and we want to divide that or share equally by the 85. Since they've said about a couple times, we know we can round the divisor first. Now, when it's a 5, think about, should I round up or should I round down? What is a close multiple to either 80 or 90 that I would like to use with my, my dividend? And so that's when people will make their own choice, and you can decide what you want to use. But some will go up and have 4,000, and some will go down and have 3,600. And if we go with, say, 3,600 and use the 90, okay, because that 36 is a multiple of 9, then we have our rounded work here, divisor and dividend. 36 divided by 9 is 4. Bring down the 0. And then about 40 quarts, about 40 quarts would be needed. Okay. Big gap. Oh well, we're over it. And the last one, Peggy has saved $9,215. Great job, Peggy. If she is paid $45 an hour, about how many hours did she work? So she has $9,215. And she's paid $45 an hour. Bravo. That's a good rate there. So we want to round the divisor first. Think carefully about how you want to round this. You could, again, some kids will go to 40, some kids will go to 50, and it's really up to you. You choose now before I do it. And then I'm just going to say, let's stick with 50 and 10. But watch out, if this is 9,000 and I go up to 10, it's going to be 10,000, and I've added another place value position. So that's what's tricky about this one. If you do work with the 50 and you go up, you're going to have, instead of 4 digits, now I have 5. So offsetting the zeros, I still have 10 divided by 5 for 2, and then I have 2 more zeros instead of what we previously did. Now, if you had used the 9, you would get a slightly different estimate, but that's okay because estimates may vary. That's what we love about these. Okay, so about how many hours did she work? Let's write our statement and we'll be done. She worked about 200 hours. H-O, hairs, about 200 hairs. H-O-U-R-S. There we go. And I hope this was helpful and maybe slightly entertaining, but I will see you on the next video. Bye for now.